Hi there, and welcome to today's class. For today's class, we'll be looking at the concept of logarithm. Now, what exactly is logarithm? Now, let's look at this. Let's say the logarithm, which in short is log of a number, let's say a to a base b, is equal to a number, let's say x, such that b raised to power x is equal to a. All right, that's the concept of logarithm. All right, so I'm saying the log or the logarithm of a number a to a certain base b is equal to a number such that the base raised to that number should be equal to this one here, all right? The number there. So that's it. So this is how logarithm means. So from this now, I'm saying that this one here, the base to power, the answer here is equal to the number that I'm taking the log. So I'm having this. So what you have here is basically the relationship between indices and logarithm. Okay, so we treated indices in the last class. If you missed the video on indices, I'll drop a link in the description of this video so you can get the video on indices. All right, so this is how logarithm works basically. So with this now, I'm saying this. I'm saying that let's take for example, if I have log 32 and the base is 2, this is equal to what exactly? Now, what this means here is that I look for a number such that if I raise 2 to that number, I'll have 32. That's what it means. So the question is now this: 2 raised to power what gives you 32? So if you do your 2 times table, you have that 2 times 2, that's 4, times 2, that's 8, times 2, that's 16, times 2, that's 32. That means I'll have to multiply 2 by itself 5 times to get the value 32. So that means this answer here is equal to 5 because 2 raised to power 5 is equal to 32. So this is just the basic concept of logarithm, all right? So next up, let's look at some of the laws that governs logarithm. Let's look at the laws of logarithm. Right, so the first law of logarithm is called the addition law, right? The first law of logarithm is called the addition law. All right, for the addition law, the addition law says that if I have the log of a number to a certain base plus the log of another number still to the same base, that my answer is equal to the log of the product of the two different numbers to that same base. So I'm saying this: if I have the log of, let's say, a number m to a certain base a plus the log of another number, let's say n, to the same base a, this is equal to log to that base into these two numbers multiplying. I'm having m times n. That becomes mn. So I have this. All right, so this is the first law of logarithm called the addition law of logarithm. So let's take an example here. So for example, if I say log, let's say 5 to base 3 plus log, let's say 10 to base 3, right? How do you evaluate this? This would be equal to log, we said you multiply these two, that becomes 5 times 10. Don't forget the same base, they must be of the same base, that's 3. And this will be equal to log 5 times 10 is 50 to base 3. So I'm having this. So this is basically my addition law of logarithm. Let's try something else. What if I have something that looks like log 3 to base 5 multiplying log, or let's use addition, so plus log, let's say 10 to base 2 in this case. Right, for this one here, it will be wrong for you to say log 5 times 10. That would be wrong. And the reason is because if I look at this one here, the bases are not the same. The base here is 3, for this is 2. So in this case here, technically, the addition law would not work, okay? Although we can still change the base. We look at the concept of changing the base of a logarithm much more later. For now, let's proceed with the laws of logarithm. Let's look at the second law of logarithm called the subtraction law. All right, so let's look at the subtraction law of logarithm. For this one here, now the law is this: if I take the log of, let's say, m to a particular base, let's say a, and this time it's been, I'm subtracting log n base a from this. From the law of logarithms here, we have that this will become log to base a into this divided by this. So it becomes m all over n. All right. So this is basically the subtraction law of indices. This is how it works. All right. If I have two logarithms of the same base subtracting, I'll simply have to divide the numbers. That's this over this. That's it basically. All right. An example. Let's say I have log 24 base 5 minus log 4 base 5, for instance. Let's say I have this. Now, what do you have here? This will be equal to log, since they are both base 5, I'll have base 5 into this divided by this. So it becomes 24 all over 4. And this is equal to log the base 5 into 24 divided by 4 is equal to 6. So I'm having this. So it becomes log 6 base 5. So this is how the subtraction law of logarithm works. Next up, let's look at the third law of logarithm, which in this case would be the index law. Let's look at the index law of logarithm. All right, so let's look at the index law of logarithm. Now, this is what the index law of logarithm states. It states that if I have, or if I take the log of a particular number, let's say m, to base a, such that this m has a power b, that my answer will be equal to. So what happens is this: if I take the log of any term raised to an index, all right, now what happens is this: the index comes down to this point. So that means b comes down here, and I'm having b into log. So I'm having log m base a. So I have this. All right, so this is the simple concept of the index law of logarithm. We'll take an example for this. So an example is this: if I take log, let's say 5 to power 3 to base 2 for this. Now this will be equal to, what happens is this: since I'm taking the log of a particular number with a power here or an index, the power comes out this way. All right, so the power comes before all of this. So 3 moves down here. I'll have 3 log 5 to base 2. So I'll have this. All right, so this is how the index law of logarithm works. Let's look at our fourth law of logarithm. All right, so let's look at the fourth law of logarithm. So the fourth law of logarithm says that the log of 1 is 0. Please, something very important to note, right? The log of 1 is 0, all right? The log of 1, okay, better still, it can be said that the log of 1 to any base is equal to 0, except that base is 0. So I'm saying this, that the log of 1 to a base a is equal to 0. That is if a is not equal to 0. All right, that's the condition. Okay, of course this is in tune with the law, the zeroth law of indices, which says that any number raised to power 0 is equal to 1 except 0. So that's the concept of this. So what this means is this means that, for instance, log of, let's say, 32 to log of 1 to base 32 is equal to 0. Okay, so log of 1 to, that's log of number 1, that's 1, to any base is equal to 0. That's if the base itself is not 0. So this is the fourth law of logarithm. All right, the next law of logarithm is this. Law 5 says log of a number, let's say a, to itself as a base is equal to 1. All right, that's the fifth law. All right, the log of a number to that same number as a base is equal to 1. Now, what this means is that log 3 to base 3 is equal to 1. Log 5 to base 5 is equal to 1, and etc. All right, so the log of a number to itself as a base is equal to 1. And this makes sense because we said this, the base raised to power this, should give you this. And of course, we have that 5 to power 1 is equal to 5. So that proves that this law is true. All right, so the final thing we'll consider is the change of base. Let's look at the sixth one, the change of base. So how do we change the base of a logarithm? How do we change the base of a logarithm? Let's say I have log a to base b. For this case here, observe that the base of this logarithm here is base b. Now, what if I want to change the base to any number I choose? Let's say I want to change it to base d, for instance. So how do I change to base d? The concept is simple. If I want to change this to base d, this will be equal to log of the number here, a, to base d all over log of the base b to that new base d. So observe that I've changed this concept here from base b to base d. And the idea is simple. I'll take the log of the number to my new base, which is d, and I will divide it by the log of the base, which is log b, to the new base I want to get, which is d. So this is how you convert, or this is how you change the base of a logarithm. All right, so this is how we change the base of a logarithm. All right, let's take an example. So I'm saying this. Let's say I have log 5 base 3, and I'm asked to change this to a number in base 2. Right, so change this to log base 2. What do you do? Very simple. That will be equal to, I have log of this one first, which is 5. I want to change it to base 2. So it becomes base 2 all over log of the base now, which becomes logarithm of base 3 to my new base, base 2. So I have this. All right. So with this now, I have successfully changed the base from base 3 to base 2. All right. So these are like the 6 laws that will combine together to solve problems involving logarithm. All right, let's take some examples and then see how we can solve problems on logarithm. All right, so finally for today's class, let's see how we can work out these examples applying the different laws of logarithm that we just learned. So for this example, I'll do question 1 and 2 while you try question 3 and drop your answer in the comment section. All right, let's start with question 1. So question 1, there I have the log of 9 to base 3 plus the log of 15 to base 3 minus the log of 5 to base 3. All right, so I'm asked to simplify this. Now, what do I do here? The idea is very simple. First things first, if I look through these, they all have the same base. Now, since they have the same base, it means I can work them out. So let me work this out. What do I have there? This will be equal to, now since I'm having the same base here, what do I do? I'll just take a common base, that's log. I'm having log of base 3. Now, since these two are adding, I'll have to multiply them. So it becomes 9 times 15. Then this is subtraction. That means I will divide. So divided by what I have here, 5. So it's this simple, all right? 9, addition law, you multiply the numbers there. Subtraction law, you divide. So this is like me saying this is equal to log base 3. This becomes 9 times 15. 9 times 15 divided by 5. So I have 5 here. All right, so I'll have to work this out, yeah? So 5 here, 1, 5 here, 3. Of course, 5 can divide 15 to give you 3. If I work on this, this is equal to, I'm having log 3, so it becomes log of base 3. I'm having 9 times 3, that gives you 27. So I have 27 here. So what next? My next task would now be, is there any way I can still break this down? Possibly, yes. Now from here, I will now recall that 27 is actually 3 raised to power 3. So this becomes log of base 3. 27 is simply 3 to power 3 because 3 times 3 gives you 9 times 3 gives you 27. So 3 multiplies itself 3 times gives you 27. From here, if I now bring up the power law of logarithm, so if I now bring up the index law of logarithm, this will be equal to, we said if I take the log of a number to a certain power, the power comes down. So it becomes 3. This 3 now comes down here. So it becomes 3 into log 3 to base 3. I'm having log 3 to base 3. So I have this. So what next? Recall that we said the log of a particular number to the base is equal to 1. So what does it mean? It means that log of 3 to base 3 is equal to 1, as we said. So what does that mean? That means that this becomes 3 into log 3 to its own base, that's 3. That gives you 1. So it becomes 3 times, this is 1. 3 times 1 gives you 3. So my answer to this question is 3. All right, let's try the second example. So example number 2, I have half. So half log 25 minus 2 log 3 plus log 18. So I have this. All right, so let's get this solved. All right, so how do we solve this? So for this one here, the first task would be, what is my base? Okay, for this question here, we can say that the base is 3. In a question of this manner here, what's the base? Now, note that this is called so this is called the log of a number to base 10. All right, so I'm saying this, if I have log 5 base 3. Here, it's obvious that the base is 3. But if I just have log 5, for instance, in a case where you have just log 5, please note that the base is always 10. All right? So the base in this case is 10. That's the base there. All right. So in the case where the base is not indicated, note that the base there is 10. This is something you should bear in mind before we start solving this question. All right. So having said that, let's look at this here. Okay, so from here, our task would be this. So the first thing is this. We've noticed that, or we've noted that the base here is base 10. Okay, so what next? Our next task would be this. In a case where you're having subtraction and addition, my advice would be take the addition first before subtraction. So what do I mean? What I mean is this. This becomes, I will rearrange this to become half into log 25. Okay, so I'm bringing the addition first. So it becomes plus log 18. Then this one here, minus 2 log 3. Please note this, all right? So bring up the addition first and then shift the subtraction to the extreme. So I have this. So what's next here? Let me bring out some of the laws from this. The index law of logarithm, we said if I have this case here, it means that this man, just like we had here, all right? So this man here can come this way as the index of this number here. That means half can come here as the index of this. So I'll have something that looks like this. Log 25 into 1 over 2 as the power, plus I'm having this one here as log 18 minus, of course, just as we have here, these two can come up here as the index. So I'm having log 3 to power 2. So I have this case. So what's my next task here? My next task here would be, let's see how we can possibly simplify all of this. So this would be equal to, I'm having log 25 to the power 1 over 2. If I have 25 to the power 1 over 2, with the concept of indices, this is equal to the square root of 25. And we know that the square root of 25 is 5. Okay? That means this one here, the value is 5. So I have this. So I'm having log 5 as my answer, plus this becomes log 18. Okay, so fine. I'm having log 18 minus log 3 to the power 2 means 3 squared. Of course, 3 squared is 3 times 3, which of course is 9. All right, so bringing the addition and subtraction law of logarithm here, what do I have? This will be equal to, I'm having log, don't forget these two are adding, and we said when they're adding, you simply do what there? Multiply the numbers. So it becomes 5 times 18. I'm seeing a subtraction here. That means division. So it becomes divided by what I have here, which is 9. Better put, this will be equal to, I'm having log of, this becomes 5 times 18 divided by 9. I have this. Okay, so what happens here? From here, 9 here, 1. 9 can cancel 18, gives you 2. So from here, I'm having something that looks like this. Something that looks like logarithm of 5 times 2. That's 5 times 2. If I work this out, this is equal to logarithm of 10. If I have log 10 here, what comes to mind? Don't forget that we said the base here is always what there? 10. Okay? So that means if I have log 10, this is the same thing as saying log 10 to base 10. They're the same thing. So when I just take the log of a number, the base is always 10. And from here, I know fully well that log 10 to base 10 is equal to what there? 1, as we said. So we said that the log of a number to itself as the base is equal to 1. That is if the number is not 0. And in this case, the number is not 0. So I have this as my answer. All right. So your task is simple. Try to solve question 3 and leave your answer in the comment section. If you enjoyed this video, make sure you like the video and leave a comment. Also, you can get all of my classes on mathematics, physics, chemistry, and other engineering courses on my website. Simply visit www.jonahemmanuel.com/courses, and then you check for the JAM/wire classes, and you see hundreds of videos on physics, chemistry, and mathematics. Then you can get the course and get more information on this. Thank you and see you in the next class.